Hi, welcome to Math150 Multivariable Calculus. Hopefully this is the class everybody was expecting. Yes? There's just more people in here than PeopleSoft has recognized in the class. So how many of you have not received an email from me? It was sent maybe around 4 a.m. Check and make sure that you have received an email from me about this class. If you've received an email, it means I have you on the list. If you have not received the email, you may be registered for the class. I just do not have a record of it yet. This is a very easy time of the semester to talk to the registrar and sort out problems like this. Years ago when I was teaching at Brown, I had a student who was taking multivariable calculus with me. They had some issues and I was chatting with them about their schedule and found out that they were taking 2 different multivariable calculus classes the same semester because they really wanted to make sure they could understand the material. And somehow the registrar system did not catch this and was allowing the person to sign up for 2 classes in the same subject of the same content. So, never assume everything is correct with your system. Always check and make sure that you are registered for the classes you think you are registered. What I want to do in this class is I want to use class time more effectively. Out of curiosity, how many people are freshmen? First years? So a lot of you are. So you might still remember the biggest difference between high school classes and college classes is contact hours, right? In math in high school, you meet daily, and you meet for more weeks. And in college, when the material gets harder, we decrease the number of days we meet, and we decrease the number of weeks we meet. In some sense, of all the classes I teach, multivariable calculus is the class I hate the most. Sorry. In terms of just the amount of content we have to cover and the amount of weeks we have to do it. It can be done, and the solution is typically to go through things very quickly and not have enough time to go into things in as much detail as you would like. I would prefer not to do that. What I would prefer to do is to use class time more effectively. So how do we use class time more effectively? The best way is for you to be prepared for class and for us not to spend class time on more standard things that you are getting at home. And so what I'm going to do is I'm going to make you an interesting deal. 60% of your grade will be a 92.5, which is right on the boundary of an AA minus, if you come to class prepared. That means you watch the video beforehand. If there are questions you have about the material, if there are things that you want to see in greater detail in class, let me know and I will make sure that I lecture about them. But if there are things that everybody understood from reading the book, then let's not waste time on that. Let's actually spend time doing more examples in class or doing more applications. And if you do that, 60% of your grade will essentially be an A. Life happens. Anybody who thinks that this doesn't happen, you have not been around enough. At the last minute, a roommate will go through a crisis. Something will occur with very little warning. 3 times all semester you can tell me, Professor Miller, something happened. I wasn't able to be prepared today. And as long as you tell me before class, you're absolutely fine and you're excused from that. But you have to let me know beforehand. This is to prepare you for the real world where you do not show up and tell your boss an hour before the presentation, oh yeah, I wasn't able to prepare the slides for the big pitch today. So as long as you give me at least a day's notice. Same thing goes if any of you are going on job interviews, if you have sporting competitions, if you have big plays or anything like that. As long as you give me notice, I am absolutely fine about moving the deadlines back and forth. I will record all the lectures, so we will be using, for the lectures you watch at home, the lectures I gave, I think, in 2014, where I actually hired somebody to come in with a really good camera and professionally record it. For those of you who were paying attention before class and heard me mumbling some things about why this tracking system wasn't working, for the most part it works pretty well. It's easy to do. I can have it following me if I want, if I enable this device over here, but I want to make sure it stays in focus. I want to be able to use class time for more supplemental discussions, to actually talk about how would you use this stuff, why would you use this stuff, who cares about this stuff. So I have many hats. One of my hats is I serve on the Mount Wheelock Regional School Committee. I would have been going there for a meeting that I was chairing if it had been better weather today. All the meetings have been canceled. I will actually show you how the math we're doing can be used for multi-million-dollar real-world issues in education in terms of allocating funds. I do a lot of work in sabermetrics. Anybody know what that is? It's basically applying math and stats to sports, especially to baseball. And so I and several Williams students have been on many multi-million-dollar lawsuits. There's another one that I'm in negotiations to bring some Williams students on board on. And I want to show you how you can use the stuff we're doing for stuff like this. How many of you have taken a stats class? I'm not sure if I could put my hand up because mine was in psychology, but if you haven't taken the stats class, I strongly urge you to do so. I used to tell all students that if you know probability, statistics, and programming, you will always have a job. You may not like your job, but you will have a job. I can no longer tell you this because somebody sued her school a few years ago because she didn't have a job on graduation. And what's nice is in the Freedom of Information Act, you can actually download the lawsuit and stuff like that, where she misspells words like tuition. And she's discovered a new type of discrimination, academic discrimination. Her school did more for students with higher GPAs than lower GPAs. And according to her, her 2.6 was just as good as someone else's 3.6. Now, I almost feel that if she's leaving the school with this, that the school has failed her in some regards. But there are skill sets that are going to be valuable. And a lot of you might be trying to decide, what do you want to do this summer? With a little bit of basic math, probability, statistics, I'll make sure we cover this, you will actually have enough to already be useful. I have done a lot of consulting in the real world. I am happy to talk to you about stuff like that. You don't need to get the best answer. You just need to beat what's being done. And if you just think about that, that's a low bar in many places. A very low bar. There are people who have absolutely no idea of some of the things that can be done. And so with just a little bit of knowledge, you will be able to see a lot of inefficiencies that you can improve. Some of this will involve using multivariable calculus. One of the big things we're going to do is we're going to do regression, or the method of least squares. It's one of my favorite topics. Amazingly, of all of the stuff I have done in my professional career, the most downloaded article of mine is some notes I wrote at Brown on the method of least squares many years ago when I was a postdoc. It is incredibly powerful. And we will see how to do stuff like that. So just get a little bit of a sense. How many people here know that they want to be a math major? Okay, good. So the rest of you I have to convince. Excellent. Okay, I like the challenge. Excellent. Anybody here know what they want to major in? Okay. Absolutely fine not to as a first year, even as a second year. By your junior year, we do kind of hope that you have a major, especially by second semester senior year. But what you should be doing right now is just be open and explore. There's also a tendency for a lot of people to do double majors or more than that. I strongly advise against it unless you have a really good, compelling reason. If you double major, you have to take all the classes in both departments that they want you to. Whereas you can often just take a lot of classes and just go deep in a subject. I have a student who was a math major. He was 2 classes shy in CS, and he didn't want to do those 2 classes. He did a thesis for the CS professor and went off to CS grad school. It was absolutely fine. So don't be afraid to think of non-standard things. I am happy to meet and talk to you, grab a coffee, grab a meal, go for a walk, and just talk about various options. So I love to try to provide opportunities. One of them is class later in the month is not going to physically meet. We are breaking ground. Well, no, we've already broken ground. We are having the opening ceremony for the Berkshire Innovation Center down in Pittsfield. And I am going there as a representative of somebody who has been working with these people for a while. I'll be teaching a class next fall on applications of mathematics in the real world, where I'm going to try to help people get jobs and work with the people down there. So I have space to take one person from the 2 sections of Math 150. I will send you more information. If you're interested in coming down and just getting a little bit of a sense of what that's like, you definitely won't be missing your calculus class that day. If there are things that you are thinking about in terms of summer, and you're not sure about what the various opportunities are, always happy to meet and chat with you about what you can be doing. Okay. Mechanics questions. So I've already told you 60% of your grade, if you want it, will be coming to class prepared. I will assume everybody has elected that option unless they tell me otherwise. All right? But that means you must watch the video beforehand. If there are things that you are confused about or you want me to explain, you can just email me or put them on the Google Sheet. Years ago, I was teaching differential equations. I shouldn't smile so much. And linear algebra is not a prerequisite for differential equations. That's wrong. It should be. But in this department, we have decided it is not. But it's so painful not to have linear algebra, because there's a couple of things you can really do if you know just even 2x2 matrices. And so I wanted to do some of those things. And I was curious, and I said, how many of you remember 2x2 matrices? Is there anybody here who would like a review of 2x2 matrices? Silence. So everybody's comfortable with 2x2 matrices. Okay. I had little clickers where you have the numbers and you can punch in your. And so out of curiosity, I'm just curious, I'm not going to report the score to the class. How many people would like a review of 2x2 matrices? Press 1 if you want a review, press 2 if you don't. I never said I wouldn't tell future classes, I just said I wouldn't tell that class. 47% of the students, or maybe it was 43, it was over 40%, wanted a review of 2x2 matrices. And not one person was willing to speak up and say, I would like a review of 2x2 matrices. Almost surely you will be in a situation like that this semester, and oh my God, they asked that, you might get, but they'll be thinking, thank God someone asked that question. So please, if there's something that you don't understand or something you want to see further, ask me in class. Shoot me an email, put it on the Google Sheet. I will probably not be checking email live in class, unless people really want me to do that. I could have my computer open up, but I've never quite gone to that level of technology. I did have that. My daughter does ice skating, and her skating coach is on the parent-teacher organization with me, and there's some emails about people who were upset that she didn't respond immediately and took 2 hours to respond. And so I jokingly sent her an email while she was teaching my daughter figure skating, and she responded. And I yelled at you, and she goes, I know. Normally I don't do this, but I saw it was from you, and I figured, use class time productively. Think what you can do when you're at home. Send me the emails then, but don't be afraid to speak up in class. It's a great life skill. I will be giving you plenty of opportunities to speak up in class. If you make a good comment in class, email me afterwards. This does several things. It helps me get to know who you are. So unlike most professors, I really don't want to try to get to know any of you. What's the converse? What do I want to have happen? Yes, I want you to force me to get to know you. Preferably not in, we have kidnapped your daughter. If you want to see her again, I would definitely get to know you if you do that, but that's not what I want. Right? I want you to force me to get to know in a good way. This way, when I have opportunities, I will know who you are, and I will know if the opportunity is appropriate for you. And that's why I try to make myself very accessible. If I'm in my office, it's office hours. Shoot me an email, happy to take a walk, grab coffee, grab a meal, whatever. But when you leave Williams, you are going to be in a place where people are not going to be as eager to get to know you. And you need to get the skills where you will be noticed. That's where most of the opportunities come from. And so I want you to get comfortable with that. That's why I want you to be speaking up in class. Even if it's a really minor comment. Just the more times you do it, the easier it is to keep speaking when the questions become harder in later classes. It's a good habit to get into. And that's why if you say a good comment, email me after class. It'll help me cement who it was. If I have to write letters of recommendation, it will give me something to talk about. And sometimes the questions might actually look easy, but there might be a really nice subtle thing which you got, which I can actually use in letters of recommendation. Yes?
Sorry, how do we know if our comment is any good?
If I go correct or something like that, then you know it's good.
Okay.
If I go, no, that would actually destroy Western civilization, that would cause a chain reaction, in the, something like that, then you know it's a bad comment.
Okay.
Anything along the lines of a right answer is a good comment.
Okay.
If I ask what the answer is, and the answer is 15, and you say blue, no, it's not blue, and I'll try to say something nice and encouraging, and go, and then the next person who says something, that would be the right answer. But I really when I was a student, I was terrified to speak up in class. And there were a lot of times when I had the right answer, and I was just too afraid to say it, and did not have the opportunity to impress the professor and get on their radar screen. And you want to get on people's radar screens. You want people to notice you. And the more active you are able to be, the more likely you are for someone to notice you and then give you a comment. So that was actually a very good comment. So please email me so I make sure to give you credit for that. But that's at the meta level. It's at the level of the psychologists who are doing experiments on rats. Learning how rats learn is extremely important. You need to know that before you then do any experiment with rats. So that's at a meta level. So there will be at least 2 midterms. Unless you tell me otherwise, I will drop whichever score is lowest on your midterms. Right. When I was at Brown, occasionally students did not want me to do this. Because if you failed a class at Brown, it didn't show up on your transcript. But if you got a C, it would, and some people didn't want the C, so unless you tell me otherwise, I will drop your lowest midterm grade. I will also drop whichever homework assignment helps you the most. You expect to have homework every class. There will be a couple of classes where we don't have homework, but math you need to do. The more you do, the more it's going to sink in. This is not going to mean 20 problems a night. I do not care which edition of the book you have. So I will be always posting what the problems are. So if you have a different edition where I'm sure it's a coincidence that they flipped the order of a couple of problems or changed the order of 2 sections. I'm sure there was a major educational advance which said that we have to do this. If you want, you can Google the integral house. And you can see what might happen if you write a very successful calculus textbook, which goes through many, many different editions. Right? Whatever book you have is fine. So if you have an older version, absolutely fine. Yes?
So you said, as far as like emailing you that you're not prepared for class and like shifting around deadlines.
Right.
And so much of your grade is based on class readiness.
Right.
What does that actually look like? Is there like a daily quiz at the beginning
No.
of class?
No.
Or how are you assessing?
Because I don't want to waste class time doing daily quizzes and whatnot. So I am going to trust you, for the most part, to be ready and prepared for class. So that means if I drop dead, no, you don't have to pick up the chalk and give the lecture to the rest of the class. It would be nice, but I'm not expecting you to have the material that well established. But if I'm giving a lecture on Stirling's formula, what do you think you should know before class starts? At least what Stirling's formula is, yes. Yes, I got my probability class a couple of years ago, and I did pass out a test, and I did not collect it. I saw the looks of horror on their face when it was, what is Stirling's formula? And I said, I'm not going to collect the quiz, I'm not going to see, but if you can't say what Stirling's formula is, you're probably not prepared for a lecture on Stirling's formula. That's something you should have at least seen. It doesn't mean you should know all the subtleties, but you should have a sense of what's going on. The other thing is, I mentioned this meta stuff earlier. Most of my life, I don't get work or jobs because of facts that I know. Plenty of people know facts, plenty of people know things. You get things because of your interactions and your abilities to connect. I'm hopefully connecting with at least some of you right now. What I want you to do is I want you to learn how to learn. That is far more important than the actual content. My freshman year, the person who became my physics mentor told me everything we've done up till now, and this was halfway through the year in the spring, was glorified high school Mickey Mouse physics. And our jaws dropped because we had actually done special relativity, we had done Einstein's theory of special relativity and general relativity, and we're like, this is high school Mickey Mouse physics? Says, oh, now we're doing relativistic gravity, okay. And relativistic electrodynamics. It was a great class, it was intense. What I want you to do is I want you to learn how to learn. You're going to be in situations in life where you may not know a specific fact. Well, do you know how to look it up? Do you know how to read a book, read a text, and glean what's going on well enough to use it? I had a student who was applying for our summer program who the application was late. And he said, well, the reason it's late was we had to upload a PDF, and I had 2 files, and I didn't know how to merge them. What would you do if you had 2 PDFs and you want to merge them, but you don't know how to merge them? Yes?
Ask Google.
Ask Google, yes. Even my children, 12 and 10, know that, don't you just Google merge PDF or combine PDF? Yes. And it will tell you step by step how to do it. And in a few years, Google will actually tell you, you should have known how to do this based on it. But those are the skills I want you to get. Most of the facts, so let's see, I sometimes do this in 1 minute. Does anybody have a good stopwatch, a good timer? All right. All right, so you have your stopwatch? It has seconds and everything?
Yep. Do you want a backup timer too?
I would like a backup timer. So I actually give cultural credit for essentially 80s references. It also goes a little bit into the 70s and a little bit into the 90s. So if anybody can get the movie that this is from, does anybody have a watch, preferably one with a seconds hand? Well, what movie? It's with Ned Niederlander. Lucky Day and Dusty Bottoms. All right, I'm going to teach you multivariable calculus, part 1, differentiation, partial differentiation, in under a minute. All right, are we ready? So somebody give me like a 3, 2, 1.
3, 2,
All right, so let's say you have a function f of xy is 3x squared y plus 2xy cubed. If I want to take a derivative, I can take the derivative with respect to x or with respect to y. So I'm going to use a curly d to mean take the derivative with respect to x and hold y constant. So I just imagine y is a constant. So this would just be 3 times the derivative of x squared, which is 2x times y. And then over here, it would just be 2 times the derivative of x, which is 1 times y cubed. And that's partial differentiation. Done.
That was 32 seconds.
Damn it, over half a minute. Okay. That's essentially half the class. You know, how do you take a derivative of a function with 2 variables? Well, consider one fixed. Okay. Now, this is a math class. We have to do things theoretically. We have to prove things. We have to have advanced theory. And things are very different in several variables than in one variable. And the biggest difference is how you approach limits. So has everybody copied this down?
Not yet.
Okay. All right, then what I will do is I will just move over to here. Okay. So anybody can anybody give me the movie where they give you the secret of the Miyagi karate? It is the Karate Kid. Excellent, excellent. So in one dimension, how can I approach a point for a limit? Left and right. There's really only 2 ways to go. If I tell you a limit exists in one dimension, it's great, but it doesn't really give you a tremendous amount of information. Now, in several dimensions, and for the sake of my poor writing skills, I will just draw it in 2 dimensions. If I tell you a limit exists in 2 dimensions, that tells you a lot more. There's more ways to approach. So my kids are older now, but when my kids were young and they were in preschool, I actually had the preschool classes, each kid individually draw a bunch of sheets, like the Miyagi Secret of Karate, to personally give to every student. If I give you some strange path like this, approaching a point, the limit needs to exist along a path like this. From a computational perspective, this is a nightmare. We try to do things in multivariable calculus. Well, let's try just approaching along the coordinate axes. So I am a Bostonian. I hate New York. I especially hate the New York teams. I hate New York City. But I have to admit that there is one thing that part of New York does better than Boston. The grid system. You have to give hats off to Manhattan, which has a beautiful grid system like this, compared to Boston, where you actually have roads. Anybody know which 2 roads these are? Comm Ave and Beacon. They'll cross as to which one is above. I mean, it is a nightmare getting around in Boston. With a grid system like this, it's wonderful. But there are times when you will have a function where the partial derivatives exist if you come along the axes, but they don't exist on other paths. And so for a limit to exist really means a lot. Now, what we typically do in a first class is we ignore a lot of this, and we just work with nice functions. How many of you have seen a proof of the fundamental theorem of calculus? Not bad. We will prove the fundamental theorem of calculus rigorously. And part of it is because I want to highlight some good results from Calc 1 and Calc 2. To do a lot of things rigorously is only needed if you have painful functions. And so the question is always, what is the most expansive definition of functions you can work with? And a lot of times in calculus we say, well, let's assume my function is continuous and it's differentiable and maybe the derivative is continuous as well. You don't always need all these conditions, but by putting these extra conditions in, it often makes things easier in terms of doing the proofs. So there will be a back and forth in terms of just how much detail do we want to get into with some of these proofs. I want you to be at least aware of things, and a lot of times I will give you, here's a counterexample, and shows you that unfortunately you can't do what you want to do. It doesn't always hold. It often holds, but it doesn't always hold. One of the best examples of this is Russell's paradox. So who has heard of Russell's paradox? Okay. This is one of the greatest shit moments in mathematics. So the great Frege was preparing this monumental treatise on set theory. And Russell, I think he was around a grad student at the time, said, well, what about the following? And it completely demolished the entire theory, that there was a bad foundation. And the idea is the following. Let's let R be the following set. It's the set of all elements X such that X is not an element of X. Most things are not elements of themselves. If you look at the set of students in section 1 of Math 150, the better section, right? That set is not itself a student in Math 150. If you look at the set of integers, the set of integers is not itself an integer, right? Most things are not elements of themselves. What's a natural question you might ask about R?
What if there's only one element in that?
Okay, so what elements might be in R? Can you think of a natural number to ask if it's in R? If you look at this, what might you ask, is it in R?
0.
Not 0. So I've said R is the set of all things that are not elements of themselves. What should we ask if it's in R?
Well, I guess prime numbers is a set of something, but it's not in itself.
Right, so prime numbers would... It's written on the board.
Is that X?
Not X, because X, we don't know, X is just a general
R.
placeholder. Ah! And this is where it's fun to be a Bostonian. And I want you to get, is R in R? There are two cases. Case 1, R is in R. But R is the set of all things that are not elements of themselves. So if R is in R, what do we immediately conclude?
Or it's not
Therefore, R is not in R. So we know, since there's only two possibilities, if R is in R, that's a contradiction, so R must not be in R. Well, it's only 30 minutes past. I don't have too much of a lecture prepared. Let's look at case 2. So let's assume R is not in R.
So then it meets those rules. Then
Right, so R is the collection of all things that are not elements of themselves. Therefore, this is why it really is an oh shit moment. What it proves is that you cannot just collect a bunch of objects that have a common property and say that's a set. We have to be extremely careful in how we build up our sets. And it turns out there's only one set that is, I think, somewhat justifiable to talk about, that it must exist. It's a little bit strange to talk about the set existing. Anybody want to guess what that set is? Most basic set. And the hint is it might be strange to talk about the set existing.
Oh, imaginary numbers?
Not imaginary numbers. Because imaginary numbers at least have something. So what might be a set with nothing?
Rational numbers?
No.
That still has.
Rational numbers?
0.
Not 0. 0 is 0 something.
get
0
zero.
something. 0. You're close. I'm sorry? Nope. You're close with 0 though. What set has no elements?
Infinity.
Nope. So, I'm sorry?
Negative numbers.
Not negative numbers. Look at the Super Bowl wins of the Seattle Mariners.
Oh, okay.
What's
Come on, let's go. Seattle.
Are you so? We have two people from Seattle?
Did you? Yeah, I am. But didn't
Okay.
you ask the Super Bowl wins of the Mariners?
Yes.
So the Mariners are a baseball team.
Yes.
So then they can't.
Non-existent.
Right. Non-existent.
Yeah.
Right. So if you look at a set of years in which the Seattle Mariners won the Super Bowl, it would be the empty set. Right?
Duh.
So the empty set is actually the foundation of all of mathematics. Is we start off with nothing. And then our set rules is we can create a set that has one element. Well, the only thing we know about is the empty set. And then this is just a little fun aside. Then we can have a set that has two elements, the empty set and the set containing the empty set. This corresponds to 0, this corresponds to 1, this corresponds to 2. Each number is a subset of the previous. So the number 3 would have the empty set, the set containing the empty set, and the set containing the empty set, and the set containing the empty set. I'm not going to really go into this. Yes?
And that goes on forever.
And this is one way to build up the integers. We will not be doing this in this class. I want you to be aware of what needs to be done sometimes to prove things rigorously. So that whenever you are upset about some of the stuff I'm doing, it could be worse. Okay? We're not going to do this stuff. But I want you to be aware of what would come if you go further. What do we need to do to really be rigorous? And there is a danger that you sometimes talk about things that do not exist. All right, so what I want to do now is talk briefly about the proof of one of the most important results in all of mathematics, the Pythagorean theorem. I will assume everybody has seen the Pythagorean theorem. If not, just nod your head right now so I don't feel bad about the state of our education. Okay? This is the a squared plus b squared equals c squared if you have a right triangle. The generalization when your triangle is not right is extremely important and will play a big role in what we do later in the semester. Who is the most famous Williams alum of all time?
Pythagoras.
No. So, he is, however, the most famous Williams alum is related to Pythagoras by coming up with a proof of the Pythagorean theorem.
James A. Garfield.
James A. Garfield. So Garfield is credited with a proof of the Pythagorean theorem. Given that I am employed by Williams College, I will not say that his proof is highly derivative of a trapezoidal proof that exists, but he's given credit. There are many different proofs of the Pythagorean theorem. One of my favorites, so let's say here's A, here's B, here's A, here's B. I'm not drawing things to scale. Here's A, here's B, here's A, here's B. And so if you draw it like this, these angles are all 90 degrees. And you have two rectangles. We assume that we know the area of a rectangle. So you always want to ask, what are we starting from? What are we building up from? So we assume that if you have a rectangle that's x by y, the area is xy. We will assume that if you cut a rectangle in half and form two right triangles, that each triangle has area 1/2 xy. That the two triangles, as you move them through space, they are the same. These are assumptions in geometry. Right? We want to get to multivariable calculus. We're going to take this and go with this. I'm assuming everybody is comfortable with areas of rectangles, areas of right triangles. So the big one is a plus b squared. And I can write that as the small square and then the 4 right triangles. So it's going to be c squared plus 4 times 1/2 ab. And when you expand things out, you get a squared plus b squared. Plus 2ab is c squared plus 2ab. So the 2ab's cancel, and there's Pythagoras. And so we often put a filled-in square to represent QED, quorum demonstratum, that which was to be proved. We're done, just to wake you up that we're moving on to something new. Many, many proofs of the Pythagorean theorem. I love this proof. This is a nice proof. There are other proofs you can do. And I want to show you a proof that illuminates a lot. And we might actually have an entire lecture on the Pythagorean theorem later in the semester because it's so important. All right. Have people copied this? Can I erase? Okay. Do you need? Okay. Can I erase the picture?
Sure.
Okay. So let's talk about other proofs. How many of you remember, and I know this is dangerous, your geometry classes? So I used to always do the geometry math competition because that was the only way I knew to keep my geometry fresh. Almost every good geometry proof involves you drawing an auxiliary line. The difficulty is where should you draw that line? So for this, I want to draw an, yes?
I'm sorry, what is an auxiliary?
So an auxiliary line is a line that's not initially in the problem. but by drawing it, it gives you more information. And so there is a great natural candidate for an auxiliary line. Anybody know what that line is?
I don't see how it would make sense, but I would think it's one that bisects the 90-degree angle, but I don't know how that
So
would.
by bisect, you mean split into 245s?
Yes, but
Okay.
I'm not quite sure how that would.
So if you split into 245s, it doesn't give you necessarily good triangles to work with.
Yeah, that's what it is.
But you're close.
So the perpendicular line to C.
So the perpendicular line to C from here.
Connecting, yeah, you're right.
So why would that be good to draw?
Get two right.
Wait.
Because it gives you a total of 3 triangles now?
It gives us 3 triangles, but more than just 3 triangles. What is true about all these triangles?
They're all right.
They're all right triangles. And in fact, they're all equivalent. If this angle is theta, this angle here is 90 minus theta, so this angle here is theta, so this angle here is 90 minus theta. All of these triangles are equivalent. Now what I want to do is, again, you are going to forget most of the facts you learn in college. Primarily because most of the facts are not that important. This class is no exception. What I want you to learn is how to look at a formula, how to get a sense of the behavior. Let's look at the area of a triangle. I claim the area is a function of A and B, for a right triangle. Once I have A and B, C is determined. If you know trigonometry, we can actually write down what the answer is. I claim, however, that the area could also be written as a function of the hypotenuse and the angle theta. That if I give you the hypotenuse and I give you the angle theta, then A and B are determined. And if you know trigonometry, it's going to be 1/2 C cosine theta times C sine theta. I claim, moreover, that we have some idea of what this looks like. If I were to triple the hypotenuse, what happens to A? So if I increase the hypotenuse by a factor of 3, what happens to A? So I keep the same angle, and I have C go 3 times as far. How much bigger is A now?
I have a question.
Yes.
Is B also allowed to change?
Yep.
Then they would all be multiplied
By a factor of?
square root of 3.
By a factor of 3. If I increase C by a factor of 5, how much do I change A and B by? Factor of 5. So I claim that the area has to be C squared times some function of theta. I don't know what that function is, but just by dimensional analysis, if I triple the hypotenuse, the area goes up by a factor of 9. Now, I'm going to give these triangles beautiful names. I'm going to call this triangle 1 and triangle 2. Triangle 1 and triangle 2 completely cover the original triangle without any overlap. So the area of the big original triangle is just the area of triangle 1 and triangle 2. Notice that both triangle 1 and triangle 2 have an angle of theta. What's the hypotenuse in triangle 1? And what's the hypotenuse in triangle 2? So we know that this is also equal to A squared f of theta plus B squared f of theta. This is coming from the area of triangle 1 and triangle 2. So we have C squared f of theta is A squared plus B squared f of theta. So what would you like to do now? Yes?
Divide out of f of theta.
Right. But, based on what people have been saying about you, what's the danger? Why do I have to be careful in a math department about dividing by f of theta?
If it's 0.
If it's 0. We are not allowed to divide by 0.
But it can't be 0 because we're working off of triangles.
Good.
And so if it were 0, then the triangle would not be 0.
Good. So now we can actually justify that it's legal. That if f of theta was 0, then the triangle would have 0 area. That's not happening. Therefore, this is legal. Therefore, Pythagoras is true. This is a dimensional argument. It gives you some sense. But you've got to be careful with algebra. The biggest, most common problem people have is with algebra. I will test people's algebra right now. 16 over 64 in lowest terms.
1/4.
1/4. 19 over 95 in lowest terms.
1/5.
1/5, good. Two more. 49 over 98.
1/2.
Oh, that was fast. Wow. This is the best class I've ever had. 12 over 24.
1/2.
Wait, yeah.
What? No, you were right to wait. It's 1/4.
Oh, wait.
Come on.
1/4. I've had to get up early to shovel and to send the email to you all at 4 a.m. I may be doing the algebra wrong. I will show my work. 16 over 64, cancel the 6's and you get 1/4. 19 over 95, cancel the 9's and you get 1/5. 49 over 98, cancel the 9's, you get 4/8, which does reduce to 1/2. So clearly, 12 over 24 must be 1/4.
Man, I'm following it.
There is no such thing as proof by example. Just because a pattern holds for a while does not mean it will continue to hold. So be very careful. There's a lot of people who make mistakes. It's not the calculus that throws people, it's the algebra. Our school systems love to keep passing people from grade to grade without algebra skills. And I have plenty of students who know how to do the calculus, but they don't know how to do the algebra that comes afterwards. So if you do have algebra problems, please let me know. Happy to talk to you about things like that. All right, so for the last little bit, I just want to put 4 formulas on the board. One of the formulas is correct, the other 3 are wrong. So A wins P% of the time, B wins Q% of the time. And these two teams are going to play each other, and you want to estimate what is the probability that team A beats team B. And the 4 formulas are P plus or minus PQ over P plus Q plus or minus 2 PQ. So there are 4 different formulas depending on, do I choose the plus or the minus sign up top? Do I choose the plus or the minus sign down below? For extra credit, and I think I said it was due on Wednesday, which formula has a chance of being right and which ones are wrong? So one of the things I always want you to do is think of extreme cases. Can anybody give me an extreme case about these teams?
One team wins 100%.
One team wins 100% of the time. Is there anybody here? I know we have 2 people from Seattle, right?
Is there another one?
No. I'm saying, is there anybody here from Cleveland?
So it was 0% of the time?
Well, so a few years ago, the Cleveland Browns won no games, and they had won, I think, 3 games over 4 years, or 4 games over 3, something like that. So you can have a really good team, you can have a really bad team. If you have a team that wins 100% of the time, what should happen when they play?
Win.
They probably should win. So I want you to think about extreme cases that you could try. My brother and one of his friends years ago on a very old baseball game on the Mac created the ultimate players. My brother created the ultimate hitter who always hit a home run. His friend created the ultimate pitcher who always struck everyone out. And they faced. And the computer just hung for over a minute trying to figure out what the hell to do in a situation with a pitcher who always strikes everybody out and a batter who always hits a home run. And eventually the computer came up with an answer. And I don't know how the computer came to this answer. As soon as you hear it, it's the reasonable answer. Double. Your home run is 4 bases and out is 0, so the computer said split the difference, make it a double. There will be times when you'll put in things and you may not be able to get a reasonable answer out. What might be a situation where you might not expect to get an answer?
When they both win 0% of the time?
When they both win 0% of the time, it's the toilet bowl, right? The 2 teams with the worst record, oh dear Lord, we have to watch. Someone's going to win, right? Maybe not. Maybe the game just doesn't end. Or you could have 2 undefeated teams play. And so my question is, can you come up with a justification for one of the following 4 formulas? So I've done a lot of work in baseball mathematics. I've done lawsuits. I've actually written a paper, not on this, but on more advanced formulas. If you know the Pythagorean one-loss formula or the win expectancy that you often see in websites, I am responsible for the theoretical justification for that. Yes?
Did your work contribute to Amazon Web Services, like live percentages, like for football games?
No, but I mean, similar mathematics. And I know other people who have done mathematics along these lines. And so when the camera is not rolling, I am happy to tell you about conversations I've had with GMs of Major League franchises and whatnot. Who knows which college has the oldest alumni network? Ours, okay? It is extremely valuable. I have a former student now who is working in analytics at a major league franchise. I have another one who is working not in analytics but close to that in another franchise. We have Williams alums who own major league franchises. You know, if you are interested in stuff like this, we have a tremendous wealth of resources. This is why you go to a school like this. Yes, I am having you watch classes at home. You know, this is not Khan Academy. You know, this is to use this as a booster to get us to an interesting place and to use class time productively. I want to be able to talk about stuff like this and to talk about really how to look at math. As you go further and further, you're going to get more involved equations, or you're going to have to model things that are so complicated you can't capture all the key features. Anybody know about Galileo's experiment? He dropped 2 spheres off the Tower of Pisa, and the question was to see if mass affects the time of descent. Okay, what were the colors?
The colors?
Yeah, what were the colors of the 2 spheres?
Red and blue.
That's what I
Really?
did.
I have no idea.
Yeah, I have no idea. Right? Why do we have no idea?
Nobody wrote it down.
So one possibility is nobody wrote it down. Why did nobody write it down?
It doesn't matter.
It doesn't matter. I can come up with a situation where it does matter. Imagine the spheres have been sitting out in the sun for a long period of time. Now why might color matter?
Because the sunlight's going to affect how much they weigh.
It's not going to affect how much they
Some
weigh.
property of them.
Well, yes, what property will the sunlight affect? You could expand. It could be hotter, and maybe a hot object has a different fall. But if you have 2 balls that have been sheltered, and it's really hard as a Patriots fan not to talk about Deflategate right now, but if you have 2 balls like that and you drop them, the color should not matter as they're falling down. And that's why we don't include that in the model. But maybe the mass is not enough. Maybe the shape matters. You know, if we drop 2 spheres, is that different than a sphere and a pancake? Probably. So it's which things can you account for in your model, and how good of an answer can you get? A lot of times we can't get closed form solutions, so we have to resort to Monte Carlo simulations, and we will talk about how to do that. So this is a good place to stop.